In the previous video in this series, I parameterized the nozzle geometry, completed meshing, then set up a fluid flow simulation in ANSYS Fluent. In this demonstration, I'll use the Design Exploration Response Surface Optimization system to optimize the nozzle geometry by maximizing its total shear force on the impact surface. During the run, I can see the solution by right-clicking the solution cell and clicking Show Solution Monitoring. At this point, the solution is complete. Returning to the Project tab, I'll double-click the Results cell to open CFD-Post. I can color the impact wall surface according to the wall shear in the Y direction at this location. The wall shear distribution looks reasonable. Now I'll write an expression that will calculate the total force in the Y direction produced by the nozzle, and set it as an output parameter. Our goal in the upcoming optimization is to maximize this value. With the output parameter set, I can start the optimization by adding a response surface optimization system. In the Design of Experiments tab, I'll set the lower and upper bounds for each input parameter. The barrel radius may vary between 1.5 mm and 2.6 mm. The exit radius may vary between 1.5 mm and 4.3 mm. And finally, the entrainment radius may vary between 1.8 and 2.6 mm. When I select Preview, Workbench creates 15 design points based on the variable ranges. I can compute the wall shear for each geometry by selecting Update. The Fluent solver will run for each iteration and the output parameter will be calculated after each run. From the values generated by the design points, the response surface optimization system creates a response surface. Using an interpolation method, the location of the optimization targets are determined from this surface. To find the geometry that produces the maximum total force in the Y direction at the impact surface, I'll set an objective in the Optimization tab and maximize this variable. When I select Update, Workbench interpolates a set of candidate points which represent geometries that maximize the wall shear. I can verify the candidate point by right-clicking it and selecting Verify by Design Point Update. This automatically updates the geometry with the optimized parameters and runs the analysis to confirm the predicted performance. After the update, I can view the optimized geometry, and here it is side by side with the original geometry. And this concludes this demonstration showing you how to simulate and optimize a geometry using ANSYS Workbench Design Exploration and ANSYS Fluent.